Look up at the night sky. Let your eyes adjust to the darkness, and you'll see a tapestry of stars stretching endlessly above you, a silent reminder of how small we truly are. For most of history, we believed Earth was the center of everything, a unique, solitary home in a vast, empty void. Our ancestors gazed upward and imagined the universe revolving around us, making our world feel special, even sacred. Our myths and philosophies grew from this sense of cosmic importance. But science changed everything. With each new discovery, our understanding of the universe expanded, and our place within it seemed to shrink. We learned Earth orbits an ordinary star, one among hundreds of billions in the Milky Way, itself just one of countless galaxies. The universe, it turns out, is far vaster and more mysterious than we ever imagined. Each discovery pushed us further from the center, forcing us to reconsider our place in the universe. The more we learned, the more we realized how much we have yet to understand. If our star and our location aren't special, is our planet? Could there be other worlds, circling distant suns where life has also taken root? The universe is ancient and filled with the same ingredients as Earth. The atoms that make up our bodies were forged in the hearts of long-dead stars, scattered across space and time. The laws of physics and chemistry are universal. The same rules that shaped our world operate everywhere, from the smallest atom to the largest galaxy. It would be arrogant to think life sparked only here. With so many worlds, so many chances, perhaps life is not a miracle unique to Earth, but a natural outcome of cosmic evolution. So, we search, not with certainty, but with curiosity. We build telescopes, launch probes, and send signals into the dark, hoping for a reply. We point our instruments to the stars, listening for echoes of other worlds. Each signal, each discovery brings us closer to answering the age-old question, are we alone? The quest for another Earth redefines our place in the cosmos and fills us with wonder. In searching the stars, we discover not just the universe, but ourselves, fragile, hopeful, and forever curious. For centuries, the only planets we knew were our solar neighbors: Mercury, Venus, Mars, Jupiter, Saturn. These familiar worlds, orbiting our sun in predictable paths, were the only examples of planets humanity could study. Our understanding of the cosmos was limited to what we could see with the naked eye, or through early telescopes, and the idea of other worlds beyond our solar system was little more than a dream. The idea of planets around other stars was pure speculation. Ancient astronomers wondered if the twinkling lights in the sky might be distant suns, perhaps with their own families of planets, but there was no evidence, only imagination and hope. That changed in the 1990s, when astronomers found the first exoplanet orbiting a sun-like star. This discovery was a turning point, opening a new era in astronomy, and forever altering our view of the universe. Suddenly, the universe was crowded with worlds. Each new discovery hinted at a cosmos far more complex and vibrant than we had ever imagined. The Kepler Space Telescope revealed that planets are common. There are more planets than stars in our galaxy. Kepler's mission transformed our understanding, showing us that planetary systems are the rule, not the exception. Our galaxy is a bustling metropolis of planetary systems. Each star you see in the night sky likely hosts its own collection of planets, some wildly different from anything in our solar system. The lonely universe of our ancestors is gone. We now see a cosmos teeming with undiscovered lands. The night sky, once a map of mystery, is now a gateway to countless new worlds waiting to be explored. Astronomy has shifted from observation to exploration. We are no longer just stargazers. We are cosmic explorers, charting the unknown and seeking out new frontiers. Thousands of exoplanets have been confirmed, with thousands more awaiting discovery. Each new planet adds a piece to the puzzle, revealing the astonishing diversity of worlds beyond our own. We've found gas giants hugging their stars, orbiting so close that their atmospheres are scorched and their years last only days. Rocky worlds, icy planets, and everything in between have been discovered, each with its own story to tell, and systems with multiple suns. The diversity is breathtaking. Some planets experience double sunrises and sunsets, painting skies with colors we can only imagine. We've gone from knowing one planetary system to thousands, each a unique experiment in cosmic evolution. The possibilities seem endless. The search for Earth 2.0 is truly underway. Somewhere out there, a planet may exist with oceans, continents, and perhaps even life. Every new world is a potential home, a new chapter in the story of life. Each discovery brings us closer to answering the age-old question: are we alone? The universe is far richer than we ever imagined. With every planet we find, our sense of wonder grows, and the story of the cosmos becomes ever more extraordinary. With a galaxy full of planets, which ones could host life? Not every world is a paradise. Location is everything. Earth is just right. Unlike scorching Venus or frozen Mars, enter the Goldilocks zone, the region around a star where temperatures allow liquid water. Too close, water boils away. Too far, it freezes. Liquid water is essential for life as we know it. Finding a planet in the habitable zone is the first step in the search for life. The size and location of this zone depend on the star. Red dwarfs have tight, close-in habitable zones. Big stars have wider, farther ones. When we find a rocky planet in the zone, excitement surges. But it's only the first clue. The right orbit is just the beginning of the search for another Earth. Among the exoplanetary systems, TRAPPIST-1 stands out. Just 40 light-years away, it orbits a dim red dwarf, barely larger than Jupiter. TRAPPIST-1 boasts 7 rocky Earth-sized planets packed tightly around their star. If you stood on one, the others would loom in the sky as visible disks. At least 3 of these worlds orbit in the Goldilocks zone, making them prime candidates for habitability. These planets are likely tidally locked, one side in perpetual day, the other in endless night. The most habitable region might be the twilight strip between. TRAPPIST-1 offers a glimpse into the diversity of planetary systems and the possibilities for life. It's a cosmic laboratory, a postcard from a strange and wonderful neighborhood. The galaxy is filled with planets we don't have, super-Earths. These rocky worlds are larger and more massive than Earth, but smaller than Neptune. A super-Earth in the habitable zone could have a thick atmosphere, better shielding life from radiation and stabilizing climate. Stronger gravity would flatten landscapes and favor sturdy, low-to-the-ground life forms. Flying might be rare. Gliding creatures could ride dense air currents. Plants would be shorter and tougher. Super-Earths challenge our Earth-centric view of habitability. They might even be more suitable for life than Earth itself. Super-habitable worlds. Our planet could be the exception, not the rule. The universe may favor bigger, bolder homes for life. Imagine standing on a distant world, the sky's color, the light, all shaped by its star. Our sun's yellow-white light made Earth's plants green. On a planet orbiting a red dwarf, the dim red light would drive plants to absorb every photon, making them black or deep purple. A forest here would be a landscape of dark foliage under a perpetual red sky. Around a hotter, bluer star, intense UV would force life to adapt with reflective metallic coatings or natural sunscreens. The oceans might be shallow, the land painted in strange hues. The type of star shapes, climate, weather, and the very rhythm of life. A year could last days or centuries. The search for Earth 2.0 is a search for all the ways life can adapt to alien suns. Each world is a new experiment in survival. How do we study planets light years away? The answer: transit spectroscopy. When a planet passes in front of its star, some starlight filters through its atmosphere. Molecules in the air absorb specific colors, leaving a unique barcode in the light. By analyzing these patterns, we can identify what's in the planet's atmosphere: water, methane, carbon dioxide, and more. This requires powerful telescopes like the James Webb Space Telescope, designed to detect faint chemical signatures in infrared. We're no longer just counting planets, we're starting to characterize them. We can tell if a planet has an atmosphere, clouds, or hazes. We can measure the mix of gases. This lets us ask, is this world truly habitable? For the first time, we're reading the stories of distant worlds in the language of light. Analyzing atmospheres is one thing. Finding life is another. We search for biosignatures, gases that shouldn't exist together unless life is present. Life alters its environment, leaving chemical fingerprints. On Earth, oxygen is abundant only because of life. Without plants and bacteria, oxygen would vanish, reacting away with rocks. Finding lots of oxygen on another planet would be a huge clue. But oxygen alone isn't enough. Geology can make it too. The real prize is finding two gases that shouldn't coexist, like oxygen and methane. On Earth, both are produced by life, but they destroy each other quickly. Their presence together would be a strong sign of biology. Telescopes like JWST are searching for these imbalances. Discovering them would be a profound moment in science, a hint that we are not alone. The search for a second Earth is more than just a scientific endeavor. It's a deeply human quest, driven by our curiosity and our longing to understand our place in the cosmos. From the earliest days, we've looked up at the night sky and wondered what lies beyond those distant points of light. For countless generations, people have gathered under the stars, sharing stories and dreams about life elsewhere. Are we truly alone, or is there someone, or something, out there, gazing back at us? The discovery of even the simplest life beyond Earth would be a turning point in human history. It would answer one of our oldest questions and forever change how we see ourselves. Suddenly, the universe would feel less empty, and our own story would become part of something much larger. Our sense of wonder would only grow, as we realize we're not just observers, but participants in a cosmic community. The stars above would transform from distant, unreachable lights into possible homes, places where life might thrive, and where new stories could unfold. Our galaxy would come alive with possibility, and we'd begin to see ourselves as part of a vast, interconnected ecosystem, stretching across the stars. Yet, as we search for other worlds, we're also reminded of the rare beauty and fragility of our own planet. Earth is unique, and its life is precious. We study our atmosphere, our oceans, and the delicate balance that makes life possible here, learning more about what makes Earth so special. The quest for Earth 2.0 is, in many ways, a rediscovery of Earth 1.0, a chance to appreciate our home even more deeply. Whether we find life, soon, or far in the future, the search brings us together. It inspires us to imagine, to hope, and to dream beyond the boundaries of our world. This journey is about more than discovery. It's about understanding where we come from, and where we might be headed. We are a species that looked up, wondered, and dared to ask if anyone else is looking back. And in that question, we find both our humility and our hope.